what is the formation of harmonics in the case of organ pipes? That is what we are going to take up. Organ pipe, of course, is of two types we know. One is an open pipe and one is a closed pipe. In the air column, whatever is present inside the organ pipe, stationary waves are going to be formed, and due to that, different harmonics we are going to observe. Simply speaking, the formation of nodes and antinodes, nothing special there. But these harmonics, how they are going to be formed in the case of organ pipes, and based on this particular concept, how to determine the speed of sound in air considering resonance in the case of air column apparatus. These are the things what we have in this slot. So, organ pipes we are talking about. When we take organ pipes, one is an open pipe, we used to call it, and the second one is a closed pipe we used to take up. In fact, open pipe means both sides it should be open, whereas a closed pipe means one side it is closed and other side it is open. In fact, these concepts only we are taking or considering in the case of pipe instruments, which of course are called even wind instruments, musical instruments like flute, clarinet and other things. So, when we consider open pipe and closed pipe separately, how the harmonics are going to be formed in them. Let us start with open pipe first. When I just consider open pipe and the formation of harmonics over here, I consider three different cases. Same pipe is considered in all the three cases. Both sides it is open. I took a tuning fork, I have tuned that one and I have kept that one above this. Then the waves which are being produced by the vibrating prongs surely will enter into the tube. When they are entering into the tube, how the stationary waves are being formed in that we need to know. First and foremost, the basic concept is at each of the open ends, an antinode is to be formed. So, there are two open ends, therefore, two antinodes we should get there. It is a must. And when once the wave enters into this, that wave exits from the other end, and after coming out of the tube, it used to strike the denser air and reflects back and comes back. That means we people are finding in this particular case an antinode formation here, an antinode formation here as a minimum means one node must be there in between these two. This must be the node, and the wave whatever is just entering this way, it is going like this and reflecting back like this to form a node in between these two antinodes. This is what we call it as the basic mode of vibrating air column in the case of an open pipe. Why are we calling it as a basic mode? For that also the reason is quite simple to understand. One node is expected here. Less than one node means 0 nodes. 0 nodes means no waves they are being formed, it is understood. So, this is what we call it as a fundamental mode of vibrating air column in the case of an open pipe. Suppose if I consider the geometric length of this pipe as L, then how much it is going to be? It is equal to lambda by 2. You can definitely understand an antinode and immediately next antinode. Two successive antinodes in the case of a stationary wave, the distance gap between them is lambda by 2. So, I can write this one as L is equal to lambda by 2. In other words, lambda is equal to 2L. Therefore, what is the frequency of vibrating air column inside? If I consider N1 as the frequency, V by lambda the general formula, which can be written as V by 2L. And one should understand this N1 itself, we call it as either first harmonic frequency, or you can even call it as fundamental frequency. Either first harmonic or fundamental frequency we can call it. Even you can name this one as 0th overtone also. In fact, we know theoretically from second harmonic onwards we count them as overtones. So, this N1 is now called either first harmonic we can call it or fundamental frequency we can call it. So, the point here is less than one node is not possible in any of the open pipes. Less than one node means no node formation. No node formation means no stationary wave formation. You can understand directly that way. So, this is actually the fundamental mode of its vibration or first harmonic in the case of an open pipe we can take. Now, come to the same concept, the next harmonic that is possible in this. Same length we are considering. Antinode is a must over here, another antinode is a must over here. That is the basic. Now, when it vibrates in the next harmonic, we will be finding one complete loop formation here and two 1/4 formations like this. So, you can find here the wave now reflects and returns back this way, forming one node here, one more node here, another antinode in between like this. So, you will be finding two node formations, three antinodes. This is the next or higher harmonic than this. If I consider this length, this now becomes 2 lambda by 2. You can simply understand it is equivalent to lambda officially. But we write this one as 2 lambda by 2 for us to have some common multiplication factor. It's 1 into lambda by 2. This is 2 into lambda by 2. Next one will be 3 into lambda by 2 and so on and so forth. What is this frequency here? Now, when L is equal to 2 lambda by 2, then I can write lambda is equal to 2L by 2. Earlier it was 2L by 1. Now it is 2L by 2. Next one, of course, we can guess it to be 2L by 3 and so on. That means when wavelength is decreasing, when speed of sound in air at that particular temperature is constant, then automatically frequency increases. So, frequency and wavelength, these two are inversely proportional to each other when speed of sound is constant in that medium. So, we can say lambda is 2L by 2. Therefore, frequency N2 if I write, that can be written as V by 2L into 2. In other words, I can rewrite the same as 2N1. That means twice the fundamental frequency. But one thing you should understand, what is this N2 to be called now? It should be called second harmonic. When it is called second harmonic, from second harmonic onwards, we count them as overtones. Therefore, we can even call this one as first overtone. Either second harmonic you can call it or first overtone you can call it. This is equivalent to twice the fundamental frequency in the same pipe. So this is the second case. Let us consider the same tube once again and let us take the higher harmonic than this. This is actually the second harmonic what we are having. Now let us consider third harmonic in the same open pipe. Then what would be the structure? Once again an antinode is formed there, another antinode is formed here. Two antinodes we need to have there at those two open ends. Now what would be the structure inside? You will be finding one loop like this, another loop like this, and you will be finding another antinode formation this way. The wave enters this way, reflects this way, thereby it forms a stationary wave. With how many nodes this time? We will be finding 1, 2, 3 nodes and 4 antinodes are being formed. This is the next harmonic than this. This is first harmonic, this is the second harmonic, this will be the third harmonic. In other words, I can say this is 0th overtone, this is the first overtone, and this can be called as the second overtone. So when we write this L is equivalent to 3 lambda by 2 in this particular case. Then what I can write now? When L is equal to 3 lambda by 2, then lambda becomes 2L by 3. Earlier it was 2L by 2, now it is 2L by 3. So what would be the frequency corresponding to that? It is V by 2L into 3. In other words, I can say 3N1. So what are the names you can give to this one? Third harmonic you can call this. Or you can even count that one as second overtone. That is the concept. So either second overtone or third harmonic you can consider this way. So these are three different examples what we have taken up in the case of both sides open pipe when harmonics are formed in them. Now what is your overall observation? Overall observation means you are getting first overtone, second overtone, third overtone and so on, like this first overtone, second overtone, third overtone and so on. Similarly, first harmonic, second harmonic, third harmonic and so on. So what kind of harmonics are formed in an open pipe? What kind of harmonics means you are getting first, third, fifth, seventh like odd harmonics. Similarly, second, fourth, sixth, eighth like even harmonics. That means you can come to this conclusion in the case of an open pipe, you can take both odd and even harmonics are formed. That is actually the concept we need to understand. So in an open pipe, odd harmonics are also formed, even numbered harmonics are also formed, like 1, 3, 5, 7 odd numbers, 2, 4, 6, 8 like even numbers. All are possible. Right from 1 to infinity, you will be finding different types of harmonics. They are being formed in the case of an open pipe. So what is the basic result you should remember? If I take for an open pipe, what is the ratio of N1, N2, N3 and so on? What is the ratio of this one is the question. That ratio is now going to be 1:2, 2:3, 4:2 and so on and so forth. That means all the harmonics there is no such harmonic which is going to be missed out from the system. Right from 1 to infinity, all odd as well as even numbered harmonics are possible in the case of both sides open pipe. So this is the first kind of a pipe, and how the harmonics are being formed we just have checked now. Let us take the second one now. In a closed pipe, I just want. In a closed pipe. Closed pipe means we should consider one side open and one side closed. This is the one. I am just considering once again 3 cases with the same tube. The geometric length of this tube I am considering that one to be L. And we know this is an open end, therefore antinode will be formed. That is a must. And this is a closed end, therefore we need to get the formation of a node there. So what would be the first or fundamental mode? The wave strikes the bottom and just reflects back this way, forming one antinode at the open end and one node at the closed end. So less than this there is no possibility. What for we can understand, one node as a minimum we are getting, one antinode as a minimum we are getting. Less than one node means no possibility for us to have a wave inside. So naturally this is going to be the value, and the total length in terms of wavelength lambda we can write it as lambda by 4. Then what I can write, L is equal to lambda by 4. That means lambda is equal to 4L. When lambda is equal to 4L, what can we write as a frequency? It is V by 4L. And once again we can write this N1 as first harmonic, or you can even call the same as fundamental frequency. So earlier in the case of an open pipe, fundamental frequency N1 we have got it as V by 2L. Now it is V by 4L. So this is the first mode or fundamental mode of vibrating air column in the case of a closed pipe. Now come to the second one. Let us take the next harmonic possible. L is geometric length again. Now this time we will be finding the wave formation this way. Wave enters this way, strikes here forming a node, and returns back this way, reflects back. There will be an antinode at this open end, one more antinode in between these two nodes now. So what you can understand in this case, look at carefully, node number and antinode number, they are one and the same. Whereas in the case of an open pipe, antinode number will be one more than the node number. That's the difference. So if you take this two nodes and two antinodes, that will be the next higher harmonic than this. So what would be the length here now? 3 lambda by 4. Now just to check this one carefully, in the case of open pipe, when first length we have got lambda by 2, second length 2 lambda by 2, third length 3 lambda by 2, that means third harmonic, and so on and so forth we have got. Whereas here after 1 lambda by 2 we are getting directly 3 lambda by, after 1 lambda by 4 we are getting directly 3 lambda by 4. That means in between these two, 2 lambda by 4 like thing we are not obtaining. After 1, it is going to 3. That means no even number that is possible. Only odd numbered harmonics we people are observing. So we can say here this L now which is taken 3 lambda by 4, then automatically lambda becomes 4L by 3. And what would be the frequency now? That frequency officially should be called as the third harmonic frequency. Even though we write this one as N3 or N2 also in the same order, but while counting, the second one should be counted as the third harmonic. So what we can understand in this case now, V by 4L into 3, that whether you call it N2 or N3, never mind, but count when we take up, this is to be called as third harmonic. When this is called third harmonic, what would be the overtone number? That is, as usual, first overtone. In the case of closed pipe, this count slightly differs. In the case of an open pipe, first harmonic 0th overtone, second harmonic first overtone, third harmonic second overtone, and so on and so forth. In a regular order we find. Whereas in the case of a closed pipe, after first harmonic, we are directly getting the third harmonic without having the second harmonic in between. That third harmonic now to be called as the first overtone as such. Now exactly in the same manner, when I take this N3, how many times it is going to be? It is now to be written as, right, N3 is equal to 3 times N1. That is the relation. So after 1, we are getting 3. What do we get in this case? We can guess directly now. What is the next number? Next odd number, 5. So this you will be finding fifth harmonic. And we can call that one as the second overtone here. So in fifth harmonic, what is the basic construction of the wave formation? If you take, there will be 2 loops in full like this. And of course, we will be finding an antinode here at the open end, second antinode here, third antinode here, one node at this closed end, the second one here and third one here. This now becomes 5 lambda by 4. That is the case. So definitely you can write the same like this now. This N5 is equal to V by 4L into 5 I can write. So what is happening here? After first harmonic, third harmonic. After third, we are getting a fifth harmonic. So one can understand in the case of a closed pipe, only odd harmonics are possible. Even harmonics are not possible. Thereby, after the first we get the third, after the third we get the fifth, then seventh, then ninth, and so on and so forth in that order. So this is actually the major difference between an open pipe formation of this harmonics and closed pipe formation of harmonics like. When we take what is the ratio of these frequencies? So this one we can call it as fifth harmonic, or you can even call it as second overtone. So ultimate result what we can observe from this one is, in a closed pipe, in a closed organ pipe, only odd harmonics are formed. That means we never used to find even numbered harmonics formed in them. And second aspect, Therefore, if I write N1 is to, N2 is to, N3 is to and so on, that now will be 1 is to, 3 is to, 5 is to, 7 and so on. But how to identify the number of harmonics and corresponding number of overtone? There is a small relation like this. If number of overtones, that is, in other words, you can even remember it like this. If overtone number is x, then the corresponding harmonic number will be 2x plus 1. Say for example, 0th overtone. Put x0, that will be 1, that is the first harmonic. If I say first overtone, 2 into 1, 2 plus 1, third harmonic. Second overtone, fifth harmonic. Seventh overtone, 15th harmonic. So that way, if overtone number is known to you in the case of a closed pipe, the corresponding harmonic number you can directly write. So this is the way we can directly convert the number of overtone number into harmonic number or vice versa. But these are the concepts one has to remember as far as the harmonic formation in the case of a closed organ pipe. Just based on the concept of closed organ pipes and harmonic formation in them, they have constructed an instrument, an apparatus, which is called a resonating air column apparatus, by means of which one can determine speed of sound in air at laboratory temperature. What is that experiment corresponding to that what we have? That's what we are going to take up now.